Oh, yes.
Good afternoon, everyone. We're going to cover section 6.1 today. When we're finished with 6.1, we'll just introduce 6.2. That's what we'll do. Next class we'll do 6.2. Next class is Tuesday, and the test will be on Thursday. Okay? So we'll go from chapter 5, chapter 6. Chapter 6 only has 2 sections. Well, we'll do 6.1, we'll introduce 6.2. This is on discrete random variables, and on the board I presented what's called a discrete probability distribution. Just one example, and I'll talk about what these are. Remember that word discrete? Countable? We'll see these values right here, 0, 1, 2, 3. Someone is attempting 3 free throws at the basket. 3 free throw shots at the basket, 3 attempts. And they can make 0 shots, or they can make 1 shot, they can make 2 of the baskets, or they can make all 3, right? And these are the probabilities of each occurrence. So there's a 51% chance that individual is going to make 3 baskets, right? There's a very, very small chance, 1%, that they miss all 3 shots and make 0 of these. So I don't understand this example I have on the board, but it's called a discrete probability distribution, because these values here are discrete. You know, they can't make 1.3 shots, right? They can't make 1.2 shots. They either make 0, 1, 2, or 3. All right. And what we're going to do with this discrete probability distribution, we're going to compute the expected value. If they're going to get 3 attempts at the basket, how many baskets do we expect the individual to make? So we're going to compute the expected value. All right. So let's compute the expected value. And by this concept, expected value, how many baskets we expect them to make. If they got a 51% chance they'll make 3, but 38% chance they'll make 2. We'll compute what's expected. How many do we expect them to make? A lot of you can already sense, though, it's around the 2 or 3. Do you agree? It's something, because there's a really high percentage here. Someone's pretty good at making free throws. It's somewhere around a 2 or 3. We'll get a number, though. We'll be able to come up with an actual value for this. So this is called the mean of the probability distribution. That's what it's called. So I'm going to write that over here. We're going to actually find what's called the expected value. They like to write it with a capital E. All right, so expected value. But it's actually the mean. It's going to be how many baskets they make on average. They make 2 or 3 on average when getting 3 attempts. So I'm going to put this symbol down too. Remember mu? So I'm going to say mu, the mean of this probability distribution. And all we're going to do is, I know you know that symbol, summation, right? All right, we're going to sum the products, x times p of x. When this is called that big E, you can write in your notes expected value. It also means the mean of this discrete probability distribution. But the formula is we're just going to sum the products here. You know, it's like Well, there's a 51% chance they make 3 of them. All right, 51% times 3. Plus 38% times 2. Plus 10% times 1. Plus 1% times 0. So we'll do all the products, then we'll add them all up. So if you want to come up with this expected value here, you want to just add another column. And we'll write x times p of x. We'll just multiply these right here, and then just add them up. So that's what we'll do to come up with this expected value. So here, you and I will calculate, okay, here we go. What's x times p of x? All right, everyone, what's 0? Here, just put a multiplication sign there. What's 0 times 0.01?
0.
And feel free to use your calculator. What's 1 times 0.1?
0.1.
1 times 0.1 comes out to be 0.1. What's 2 times 0.38?
0.76.
76. And eventually, everyone, we're just going to add these up. One more. What's 3 times 0.51?
1.53. Right?
Oh, 1.5. So here's all the extras. So we calculate all the products. But now we're going to sum these. And we'll come up with the expected value. A lot of us were guessing this person probably makes, we're expecting them to make about 2 or 3, right? Well, we'll get a number out of this. So let's see what we get. What's 0 plus 0.1 plus 0.76 plus 0.53? What's the sum?
2.39.
2.39?
Mm-hmm.
All right, there it is. So there's our expected value. The expected value is 2.39. And I know we're saying, well, you can't make 2.39 baskets, right? But that's our value. That's what we call the mean of that probability distribution.
So,
And it's neat in real life where this comes about. So our next problem, we'll do something, I know this is just shooting baskets. We'll do something like with life insurance and with probabilities of, people living and dying, things like that.
so if he has like 3 chances, he can make up to 2.39. There's the chances to.
That's exactly it. We're saying we expect this person, on average, every time they play this game, to make roughly 2.39 baskets. Even though you're like, well, they can't make 2.39 baskets, 2 or 3. But this example will help us understand when we do more and more problems, we're like, okay, to get this expected value, we'll just multiply all the products and we'll sum them all. And we'll do some really neat problems. The next one I'll do is going to deal with life insurance. But that's what we're saying here when we interpret this, right, everyone? Sometimes this person's going to make 3 baskets, sometimes 2, but on average, he's going to make 2.39 baskets.
So what is on the y side, the 0.10?
Oh, right there?
Yeah.
That one? So
Like-
that right there, that 0.10, which is 0.1, which is what, 10%? We're saying when we interpret this out of this table, this person's getting 3 attempts at the basket, right? They're going to take 3 shots, 2, 3. There's a 10% chance that that person's only going to make 1 of them. He's a pretty good shooter, right? But sometimes, the first one will hit the rim, go off. The second one goes around the rim, falls out. He only makes 1 of them.
So then the second part is there's a 38% chance he'll make 2.
I love it.
Okay, then 51% chance he'll make all 3 shots.
Yeah. Now there's a very good. There's a very small percent chance he's gonna do what? He's gonna miss all 3. Make 0 baskets. He's a pretty good shooter, but there's a small chance it could happen. Whoop, miss. Whoop, miss. Whoop, miss. 1% chance.
Okay.
Someone got this? Oh, very good. And so this next problem we'll do is it's dealing with life insurance. The problem I'm going to pull out of the book, it's on page 328. And it's just going to be another probability distribution. These are discrete variables. Right there, that's the discrete variable. These are discrete values. You'll notice they're going to be discrete again. It's going to be money, though. It's going to be like, $300, something like that. So x, p of x. If anyone wants to know where I'm getting this from, I'm taking it from the textbook. It's on page 328. It's not a specific math problem. It's just an example work. So that's where I'm getting from the textbook. It is in section 6.1. And this is $350. All right. This value has a negative 249,650. The probability 0.998937. Let me make sure I got that number correct. 0.998937. Oh, good. Hey, just like the last problem, this column right here, on the right, these two numbers, you know this, have to add up to what number? 1.0, right? Good. Just like the last one, you can add those numbers we had. They all add up to 100%. So if you're working a math problem out of the book tonight or this weekend, and they don't give you this value, they only give you that probability, then you know how to calculate it, right? All right, well in the book, this problem they gave it to you. I just want to point that out. If they didn't give this to you, just take out your calculator and go, what's 1 minus that number, and you can find this. So the number is 0.001. Sometimes they do that. 0.001063. All right. And I'll describe exactly what this is. And when this is we got another discrete probability distribution here, right? This is a life insurance policy. For an 18-year-old male. All right. And if you're wondering what amount, they always give a value to these life insurance policies. This is a $250,000 life insurance policy for an 18-year-old male. And these probabilities and these numbers, see the positive and negative? This is written in terms of that life insurance company. So if you want to call this Allstate Insurance, all right, this is Allstate Insurance right here. Here, Allstate Insurance. Now, this 18-year-old male, why is he buying life insurance? Who knows, maybe he has a child, right? Maybe this male has 2 childs, but he's purchasing life insurance. In case something happens, there's money available, okay, to take care of others, you know, if he passes away. But he's purchased this. Now, what's it going to cost him per year? This policy will cost that individual, that male, $350, right? So, do you all agree this person has a good chance of living to be 19? A randomly chosen 18-year-old male, oh, there's a really good chance, right? He's not going to die. And there's a really good chance that this company is going to collect that $350, right? And they won't have to pay anything. True? Yeah, there's a concept of life insurance. But there's a small % chance, right? Very small, that unfortunately the 18-year-old male may die. And how much are you going to have to pay out? Well, it's a $250,000 life insurance policy, but do you know why it's negative? Because they got to pay this, right? This company has to pay. That's why it's negative. But do you know why it's not $250 right here? Does anybody know that? Why that doesn't say negative $250,000?
Minus 350.
There you go. They already collected what?
350.
They already got that. So now they got the $350 from this individual. All right, now he passed away. They collected this on January 1st. He died on March 3rd. It's like, well, we already got the $350, and it's in our bank. So when we write the check for $250,000, right, to whoever he listed, maybe he listed his sister or a sibling, it's going to be, this money's going to be paid for his child, etc. But they write that check for $250,000, they're really only losing this amount, right? Because they already collected that. Does that make sense? That's why I wanted you to see, why is that number not $250,000 there? Because they already got that from him. So, hey, let's go over this again. There's a 99.8% chance this company is going to get the $350, right? Really good chance. But there's a very small chance they're going to have to pay a lot of money out. All right. This goes for each 18-year-old male. Well, guess what we're going to compute? The expected value of this life insurance company. What's expected? How much do we expect this company to make or profit off each 18-year-old individual? That's what we're getting. So if we're going to compute the expected value of this policy here for this one 18-year-old male, and when we're going to find it, but boy, before we compute this answer better come out to be positive. Because if it comes out negative, don't you agree this company will go
Bankrupt.
yeah, they'll go bankrupt. Do you agree? So there was a mathematician behind this, making sure, looking at these odds, to make sure this amount was, not too much to, someone's going, I'm not going to buy that, but enough that you're going to get some kind of little profit, right? But make sure it's not too low so you're not losing money when something happens, when there's an emergency. Cool? So there was someone behind the scenes coming up with these, they got this from looking at statistics, right? But they come up with that number. There's some math geek, right? They call them actuaries. It's like, put $350. All right, well, we're just going to compute the expected value. So what are we going to do? We're going to sum x times p of x. All right, well, let's multiply these. We'll put it here. Let's multiply these. We'll put it here. And then you and I will sum these two values. We'll add them together. Keep in mind, that's a negative, right? So this times this. I can do it on a big screen. 350 times 0.998937. I'm just doing it on a blank screen, right? All right. 350 times 0.998937. I get 349.62795. Hey, Autumn, I'm not going to round that until I'm done the final answer. Make it clear again. There we go. Everyone, I'm not going to round that number. I figure I'll add them together, then we can estimate, we can round the last number, maybe 2 decimal places or 3 decimal places. All right, what else do I have to multiply?
249,650 times 0.0.
Where's the negative button?
63.
Where's the negative?
I think it's like
Way at the bottom. I'm at the negative. Negative 249,650 times 0.001, 063. All right, negative 265. 0.37795. And what am I going to do with these two?
add them.
This answer better be positive. Right? I hope so. So, all right, what's my last answer? Remember the answer button? What's my last answer? Plus that 349.62795. $84.25. That's the expected value. $84.25. There we go. $84.25. Hey, some of you might just do all this at once. When I did this on the screen, like, see how I did it? You might just go, hey, when I do this, I'll hit this off. I'm just going to do it all at once and just go, all right, here we go. What's 350 times 0.998937? And then, isn't plus and negative a subtraction sign? So I'll go minus 249,650 times 0.001063. I mean, so you can do it all at once. I actually like when you write it like this, actually on your tests, so I can see, oh, this, in case you make an error, I can go, that student knows what to do. They just made an error right here in their multiplication of this thing. They're all 1 decimal place or something like that. Cool. So great job with that. Hey, can we talk about this? Like, what does this really mean? Interpretation. Interpretation. I thought they're getting 350 from this guy, right? This is for Allstate. Allstate profited how much? About 84. We're saying they expect to. It's expected that they're going to get, on average, how much from each 18-year-old male who purchases a policy?
84.25.
$84.25. I know. We're like, okay, what's that mean? I thought they're getting what? 350. So we got to imagine this. There's all these 18-year-old males right up here at the table. I got 350 from him. He's from Colorado. I got 350 from him. He's from Alaska. I got 350 from this, I'm the company. I work for Allstate. I collected 350 from this guy, 350 from this guy, 350 from... No one's dying, right? Okay, so my bank account here at Allstate, boy, is it increasing, right? I've got all this money in there. I'm going around, I'm collecting all this money. But then right here, this gentleman here, everyone, from Georgia, this 18-year-old male, was in a car accident. He passed away. Now, he had a life insurance policy. So now I have to pay out what? I collected this from, but I have to pay out a gigantic amount to this person. So when you see what happened with that bank account, I collected all these 350s, and I got to pay that out. So sometimes that happens, but on average, how much are they going to profit on average overall from each 18-year-old male? About 84 bucks. It's a nice small number. It's not too drastic that you're not scaring people away. Like, there's competition out there. Like, I'm not going to go with Allstate. I'm going to go with this company, right? The same thing happens. I know we're doing life insurance. This is the same thing with like car insurance. So you can think of Geico. And Geico has a bunch of actuaries. The people who come up with these numbers are actuaries. So if you're into that, that's a cool field. If you major in mathematics, you can do mathematics, and there's actuarial science degrees. You can do a concentration in actuarial science. Take a bunch of exams, but it's really for math geeks. If you really like mathematics, like doing spreadsheets and stuff like that. But it is a great career. So hey, any questions on this problem? Hey, cool. Before I leave this, the practice problems that I give you in the book, can we at least, we won't compute the answer, but can we set that up? Because the problem in your book, they didn't put it in a table. They put it in a word problem. So I want to make sure you and I can read a word problem and present the table, which is the probability distribution, the discrete probability distribution. Okay? Sound good? So this you could practice it. I know you're going to practice it for homework, but I didn't want you to go home and go, hey, it wasn't presented this way. It's in a word problem. So the problem, everyone, it's on page 332. And, whoops, it's number 27. It's another life insurance policy problem. All right. Put these out of here. But you and I will present this. Everyone, this is a life insurance policy for an 18-year-old female. And you and I will just set this up. Sound good? It's $250,000, by the way. Cool. All right, so it's a $250,000 life insurance policy. It's 1 year term. So these people, they got to pay it every year, right? 1 year. Maybe that value decreases when they get to age 25. True, just like car insurance. Or maybe it increases. All depends on the odds. A life insurance company sells a $250,000 one-year term life insurance policy to a 20-year-old female. Oh, so it's a 20-year-old female. Okay. So this is for a 20-year-old female. $200. All right. According to the National Vital Statistics Report, so these probabilities are not made up. They really got it from the National Vital Statistics Report. The probability that the female survives the year is 0.999544. All right, so I can put that as a probability, right? Mm-hmm. So you would set up your table. You're like, all right, 0.999544. All right, now what's this costing this 20-year-old female? They said $200. That's the cost of it. The policy for a 20-year-old female is $200. Where's the 200 go? Good job. So far, so good. So here's this word problem. Because a lot of these, we'll practice these textbook problems, or you might use, the software like MyStatLab. They didn't give these two numbers. They didn't give them to us. So can we all compute these? First of all, this one, isn't it going to be negative? It's going to be very close to this. So I'm just going to I'll put a negative down, get it ready. Put my dollar sign, but maybe get a calculator if you can do this in your head. What's 250 grand? Just subtract 200 from it.
200.
Ooh. Hey, 249, 800. Awesome, Autumn.
Is it always going to be negative?
Yep, always. Great question. And hey, I know Autumn, this is life insurance. We could do auto insurance. Like, I don't know, you have to tell me the number, but you drive a car, so she probably has car insurance. You probably like a 6-month or annual policy. It's an amount, maybe around here, maybe a little bit more, but it's the same thing, with the value of the car. So that's for the car, right? But something happens, the car's in an accident, they have to shell out a negative value, which means they're paying it out to you. Hey, here's your car. Here's $10,000 for your next car, right? And then you're mad because you're like, man, my car's worth 17 grand, right? All right, now everyone, they didn't give me this number. How do I get it?
1 minus.
Yeah, try it on your screen, because sometimes when it goes in scientific notation, that's why I thought I'd go over here. I'll hit the lights. 1 minus 0.999544. I'm wondering if this goes in scientific notation, because it's going to be very small. It did. So I got to hit the lights. I want you to be able to see that. These are the numbers that are going to start coming up more often. 4.56 E negative 4. How can I write that as a decimal?
0 point,
Put a point.
then 4 zeros.
3 zeros, then a
4.
And we can check this out when I put 3 zeros and a 4. 0.000456 is 4.56 E negative 4, because the decimal point was right here. And you notice it moved 1, 2, 3, 4 places. Cool. Let me hit the light so we can see that. So that's it. So hey, if it was E negative 5, wouldn't there be 4 zeros? Good. There you go. I know a lot of you like to write it that way. Cool. All right. Hey, you don't have to compute this now, but then compute the expected value of this. The question in the book, the way they wrote it, they said compute the expected value of this policy to the insurance company. So this is to the insurance company, meaning you're going to get the value that they get on average. And it should come out positive, right? If not, they're looking for trouble. Because you're talking, bankrupt. You're going to just, on average, you're going to be behind. There's no profit in there. There's no profit involved. Cool. Hey, great job. Let's do this again. Okay, we did our shooting baskets, life insurance policy. All right, let's have a little fun. Let's do this with a lottery. All right, so.
I got the one
The
question.
lottery. Oh, good, Art.
Listen, so if they have to say pay tax, do they pay tax on the $84 or like that is the profit?
That's a
right?
good question. That's a
Right.
really good question. Is part of that, is some of that tax exempt? I imagine they pay it on both.
Probably.
That's a good question.
Because otherwise they can say that's a write-off or something.
Right? Exactly it. But I wonder, then when you get that, do they pay the taxes on that 84?
Yeah.
All right. Now, when this is a lottery, these numbers I'm gonna provide for you, they're not made up. I'm taking it from a game called Keno. So I do wanna these are not phony numbers, I'm getting real lottery numbers. I didn't just wanna make them up off the top of my head. I don't know if anybody's ever played Keno. But here's a Keno card. You can play this game today. This game's played like every 5 minutes. You might have seen this before at like a local restaurant, and up there's a, somewhere located in the restaurant, maybe the bar area, there's a TV set. There's a screen, and on that screen are just numbers popping up. And people up there, and they're taking a card, and they're filling out the numbers that they want with a little pencil, and they pay $1, and hopefully they'll win or not win. So we're gonna look at that, but they have different games. They have a 10-spot, 9-spot, 8-spot. We're gonna look at the 4-spot game. So this is the 4-spot Keno lottery. But you bet, it's a discrete probability distribution. And this is gonna be mine. All right.
How many times have you won?
This?
It seems you'd be good at that.
Yeah, this game, I won't play.
Oh,
Do you wanna know why?
why?
Because I'm a math guy, right?
That's why.
And I know the odds, right, Liz? She knows, like, I don't play any lotteries. I'll play any, the only thing I'll play, Liz, is something that's free. If the game is free, I'm all game. I'll play. If it's free, I'm playing. Now, sometimes you get games like that, right? But Liz, that's a good question. Or, hey, if someone gave me some game to play and my odds of winning were more than 50%, then I'll play. Then I'm playing. But if it's less than 50%, I'm playing because we talked about the law of large numbers. All right, so I'm going to put LL in. I might get lucky on what? Just one occasion, right? In a small sample size, I might get lucky that one time and win. And sometimes it's a social thing. You do it because you're with your friends. But let's say I did it every day. Well, the law of large numbers says that over the long run, the money I'm going to get is going to be very close to the probability of winning, right? It's going to tend to go towards that probability. So if my odds of winning are less than 50%, in the long run, I'm just going to lose what?
Money.
Money. It's like, no, I'm being honest, like, I'm just being stupid. That's why, you follow me? I'm just being, because law of large numbers means, hey, you're going to do this every day? Okay. Do it for 10 years, you're going to lose money. You're just wasting time. No, I won a couple weeks ago. Who cares? Law of large numbers. But hey, I'll play free games, everyone. And one time, like Redskins radio, you could register your name for a chance to be in one of those game things. I didn't even know what it was, but hey, all right, I registered my email address, my name. Well, I was watching a Redskin game. This is 2007, everyone, the fall. And I'm falling asleep in my rocker recliner at halftime, and I hear my name mentioned on the radio. It's a true story. I'm like, they just mentioned my name. They said I won a game. So I ran over to the computer and go, what did I register for? I'm quickly trying to find out what it's called, the drive, the Redskins drive of the game. And he said, now, after halftime, if the Redskins score a touchdown in the winning drive, I get free tickets to the next Redskins, a game that year. I get to sit in the radio booth with the radio announcers. So I was all excited. If they hit a field goal, I get something very similar. All right? But if they don't get either of those in the first drive after halftime, I just get some lottery tickets. So when I'm pumped, and my adrenaline's going, because I'm like, is this a dream? Because I was when I was falling asleep on that rocker recliner. That's a true story. So the Redskins, the kickoff returner ran this ball back all the way, like 80 yards. So now I'm like, oh, they're going to at least get a field goal, right? Well, sure enough, he comes back, 3 downs and out. We went nowhere. The guy kicked the field goal and missed it. Damn. But I got those lottery. I got a T-shirt and some lottery tickets, and I won like $2 or something. I'm serious. It's a true story. But here's the other thing. But it was free, right? So that's what I mean. It was free. But then they said, hey, listen, there's one winner per week. There's 16 games in the season, right? One winner per week. At the end of the season, all 16 names will be put in a hat, actually a helmet, with pieces of paper, and they're going to reach in, and they're going to pick out one name, and that name of those 16 winners will go to the Super Bowl. Gets a package to the Super Bowl. So you had to go to a luncheon that was down Bethesda, but it's free. I'm going. I got some good food. Only 13 of us showed up. So now my chances of winning are 1 out of what? 13, this free thing, and I got free food here. I'm doing this. And guess whose name they picked? They picked my name. I couldn't believe it. So I'm all excited, and I go over, and they're like, okay, here's your itinerary. You're flying out Thursday, and you're going to come back on Monday. And I started quickly going like this, because when I realized, okay, I'm going to need about 20 substitutes to teach my classes. I just don't think I can get, hey, will you sub my class? I get to go have fun and, party at the Super Bowl. So I gave it to my dad. I gave the thing to my dad. He had a blast. So that was cool. But that's the only thing I want. So 3 games I'll play. And sometimes you win those. All right. Hey, here come the amounts of money you can win. You can win $50. You can win $5. You can win $1. or 0? Yeah, that's the thing. Sometimes you lose, right? Hey, if you're curious, this game costs $1 to play. So it costs $1 to play. Here are the odds. All right. Of course, that's very small. 0.043. These are the real odds. I did round these to 3 decimal places, though. Because once you go about 3 decimal places, that's now these should all add up to 1. If someone wouldn't mind checking it for me, because I computed these this morning. Just make sure this add up to 1. I did round those. They actually got about 8 places. And I'll put a letter and a board. All right. F the first. Three. Lottery ticket.
It's a slightly a little over 1.
It is 1?
Yeah.
All right. What is their expected value? We'll call it that answer. So, and here's my discrete probability distribution. This is for the 4-spot Keno game. And we can interpret this, just like the basketball shooting, this person has a 21% chance of getting $1. Now that's kind of funny because it costs $1 to play it. So aren't they just breaking even? You're good. So we gotta really we gotta make sense of this stuff. There's a 4% chance to win $5 though. You get $5 out of this. There's a very, very, sometimes like 3 out of 1,000 chance though, they're gonna get $50. Ooh, there's a 74% chance they're gonna lose. Cool. Now, we're going to start out with a free ticket. Someone just gets a free ticket. All right? And notice I don't have any negatives here, so that's why I'm going to start with this. A person's given a free lottery ticket. What is their expected value? Like they play this game, what are they going to expect to get? How much money? All right? From that one ticket. What is their expected value, from that one ticket? From that one ticket that they have. They can win like 30 cents, 60 cents, $1.33. If a person's given just a free ticket, so you have to pay anything, right? So I'm just here. I bought your ticket. Now go play the game. See if you win. Oh, and what's going on here? And with this game, they just fill out a bunch of numbers on a card, and then the lucky numbers pop up on the screen. If their lucky numbers are up on the screen, they win. All right. With the 4-spot game, they got to hit 4 of them. All right, so an expected value, you know what to do. I'm going to multiply these, multiply these, multiply these, multiply these, and then add them. But because this was free, this answer is going to come out positive. I mean, it's got to be at least more than, might be only some chump change. Well, let's see what we get. All right, what's 50 times 0.003? 0.15? Oh, thank you. It wasn't 0.015 or anything?
No, 0.15, yeah.
Awesome. What's 50 times 0.043? Randy, thanks. Oh, I can do that. 1 times 213 is 0.213. And I do know this number. If I multiply these, what's 0 times anything?
0.
And now I'm going to sum these, right? I'll get this sum, and that will be my answer right here. So it's 0.15 plus 0.215 plus 0.213 plus $0. 0.578. I'm going to round that because it is money to 2 decimal places, just because it's money. 58 cents. So how much do I expect to win? I got this free ticket given to me.
58
On
cents.
average, say I got a free ticket given me every day. I mean, that'd be a nice life. Every day I got a free ticket, didn't have to pay anything for this. Well, on average, I'd win 58 cents a day. If I played it one day. once a day, I got one free ticket every day. On average, every day I would win 58 cents. That's not bad though, because you go, hey, you get that every day, and you go 58 cents times 365 days, and you see how much money I collect. But that's if it's free, right? So let's do letter B, real life. But was everyone okay with that? Letter B, real life. This really kind of goes back to what Liz was asking about when I play and stuff, and I said I don't play. Because I know the answer to letter B, no question about it, it's going to come out negative. Here's the real deal. This game costs $1. So, if the ticket costs $1, what's their expected value? And this answer is going to, is $1. All right, 1.02. That's what it costs. The ticket costs $1. What is their expected value from the one ticket? What is their expected value from that one ticket that they purchased for $1? Question mark. This answer, everyone, Autumn, every time, every lottery is going to come out negative. So let's expect this answer to be negative. Cool? Someone got that? We're getting a negative answer. I don't have to do any more computations like this. I just have to do something with this $1 and this number. I have to do something with these two numbers. What do you think?
Subtracted.
Subtract. That's all I got to do. So now all the math work was done in letter A. Now we're just going, oh, but it cost you $1 to play this game. We're like, well, that's how much I'd get if it was free. But oh, I'm going to pay what?
$1.
$1. Just be careful. When you know that you just subtract these, that's all you'll do. Just remember, this answer is not coming out positive. It's coming out what?
Negative.
Because this is in terms of you. You the person, right? I put "der" there, but it's like that person playing a game. So when you do this, it's really take the 0.58 from letter A and subtract the $1. But here's what can happen. You'll be on a test. You'll go, I know I subtract, but I don't know which way. Who cares? Just subtract it either way you want, but make sure you write down a, what kind of answer? Negative answer. That's why I don't play. This is going to come out negative. This is what's expected. What's 58 cents minus $1?
42 cents.
So, even on that, you're like negative. It's going to be negative. Is that true for every lottery? Of course. Yeah, we know that. Any lottery. Unless you somehow got something free, which goes back to letter A. Sometimes you can get that, right? All right. Letter C. And when this is that law of large numbers stuff. So I mentioned law of large numbers, LLM. And we're like, yeah, the law of large numbers. You just keep doing this stuff. Over time, this is what you're what? That's what you're going to lose on average over the long run. You might get lucky in a small sample, but play this over and over and over and over and over and over and over again, where you're expected to lose 42% on average every time. And it's like, okay, then Professor Mestre, let's say I was the gambler doing this. You're like, you're wasting your time. You're just throwing out money, right? It's like I'm getting no benefit unless it was like, but it's fun, I like it. It's a communication thing with my friends. Okay, that'd be the only benefit. There we go. So and here's the question. If it still costs that individual $1 to play this game, let me just write that again. It costs $1. Each ticket. And the individual plays this, how about 500 times? The individual plays the game. 500 times per month. Maybe they play it like 10 times a day, Monday through Friday, and then on the weekends they're always playing. All right, what is their expected value from all those 500 tickets? What is their expected value? Hey, positive and negative answer.
Negative.
Excellent. This is going to come out negative, but it's going to be a lot more than this now. What is their expected value from those 500 games? We're talking the total, right?
Mm-hmm.
All 500 games combined. Well, all I have to do is something with this
Multiply.
42 cents and the 500. Now, I hope that word gives it away.
Multiply.
Multiplication. So we'll take the 500, we won't add it. We'll take 500 and just multiply it to that number. Law of large numbers, right? No, I won 50 bucks a couple weeks ago. And you're like, great. In your memory, do you remember all the times you lost? You know how many times that happened? That's what people think, it fades out, right? No, I once won 2 times in a row. I had a really good day. You're like, law of large numbers. This is what's going to happen. So what's 500 times negative 0.42?
Negative 210.
210?
Mm-hmm.
Was there any chump change or?
No.
All right, Ellen, we'll just put $210. No chump change, there you go. So per month, they're just losing what?
$210.
200 bucks. Yeah, so it's like not playing any lottery, not doing it. But some people, it's fun. If it like picks a person up emotionally, right? They look forward to it. They go to that 7-Eleven. I know they're holding up the line, but they go in there and they like it. You know, there's the value we can think about. But it's not gonna be financial. Does everyone agree? If they're doing it all the time. If they're doing it all the time, yeah, we're saying it's a waste of time. No question about it. Because it's all random. So great job with that. Seriously.
So that means they also have a 58% of a chance to win. Right?
What's that now?
They also have a 58% chance to win also, right?
Wait, 58%?
If they pay $500, so they also have a 58% chance to win. This is that is they're losing from their pocket, right?
Yeah, and that .58 wasn't 58%, right? That
No,
point-
I'm saying
Oh.
like, say they played 500 times, right?
Right.
So in the net they're losing 200.
Oh, right.
Right.
There you go. Yep. But no matter what, they're going to lose, aren't they?
Yeah.
The long run. Cool. Hey, does this sound good? What we'll do for remainder of class is we're good to go with section 6.1. I just want to introduce the formula for 6.2. That way, you'll have, like, build it. Like, actually, like, derive the formula for it. Build it up. And then, I think before you leave, since we were just talking about this keynote stuff, because you all have been wonderful today, I should at least give everyone a chance. Right? Free game. At being exempt from the final. Does that sound cool? Sound good? So before you leave, I'll give everyone a card. You'll fill it out. I'll be the lottery player. I'll run the numbers. And if you win the game, you're going to be exempt from the what? Final. So I'll make sure to do that
What do you
again.
replace that grade with?
That sound good?
What do you replace that grade with? Like
Oh.
100%?
Oh, I just thought you'd be exempt. Does that sound good?
The
It
final.
depends if it's gonna bring me down or not.
Oh, I got you. She might have fired up the final. I got you, Mia. So we got to make it even better then.
You just pass automatically. if
How
you
about
do.
this then? You're exempt from the final. That means you don't have to take it, and then your lowest test grade gets dropped. Does that sound good? So that's a guarantee. That's a guarantee the grade we want.
Go
Cool.
up.
So good? Awesome. So we'll do that at the end. Do that at the end. I promise I won't forget. All right. Hey, I'm just going to build a form. The reason I want to do this, so when we come in on Tuesday, we can jump right into 6.2. We can start using, because when you do something the first time you build it, it's the long way, isn't it? But then eventually there's a shortcut, isn't it? It's like, oh, there's functions on the calculator, and that's what we like to use. So that's what I mean. When we get Tuesday, we can start hitting on all the cool shortcuts.
So for our test on Thursday for 6.1, are you giving us like word problems with the ABC, or you're giving us the actual chart?
It would be like that, but it would be an ABC type, yeah, but I would give you that table there.
Okay.
So remember the one I did before where it was a word problem design? That I like to give you the table,
Okay.
just to be honest. I just wanted to show you that because I know you'd go home this weekend going, okay, I don't know, what's going on in this word problem? We got tables in class. Right, but I do a table and then I can ask those questions. Very good. All right, everyone, this is 6-2. This is a binomial probability distribution. All right. Binomial means two. Binomial, two things can happen. I flip a coin, it's either heads or it's tail. Hey, I wonder if the plane's gonna be on time. Well, the plane's either on time or it's late. Binomial. Right, Caitlin? I mean, I can go on and on. Either you're gonna live or you're gonna die. And so there's so many binomial, we call them binomial experiments. I'm gonna try to make the ball into the basket. Well, I'll either make it or I'll miss it, right? One of the problems deals with smokers. But they were all smokers in a study. But they looked at whether or not they started smoking before the age of 18. Okay, you either started smoking before the age of 18 or you started smoking after the age of 18. So there's so many binomial experiments, we give one separate section to it, and we come up with a math formula that we can use to calculate probabilities. So what we're going to do is build the formula. So I'll just put over here the probability of x equals x, which, I mean, it's on this formula sheet, everyone, that you'll see that you have. Everyone has a copy of this. Well, we'll just find out, well, what would be the probability for any event in a binomial probability distribution or binomial experiment. Hey, the first thing I want to talk about with the binomial experiment, if I was trying to put balls into a basket hoop, they call those trials. So you're going to hear this word trials. So that word trials will come up. You'd be like, all right, let's say I get 50 trials. Well, that means I got 50 attempts at the basket. Okay, so this word trials, don't let that word bug you. It's really the sample size. It's like that lowercase n. Sound good?
Did you make that X smaller on purpose?
I did. And I wrote it like this. The reason I wrote it like this, Angela, is because that's how it's written on the formula sheet. But I don't want that to bug anybody. So when I wrote capital X equals small x, that's the way it's presented in the book, the way it's presented, you know, even on like an AP exam. But you can just think, you and I are about to come up with the math formula and build it.
Oh, okay.
And I just thought, Angela, rather than just what? Here's the formula, give it to everyone. It's better when you and I know how a formula emerged so we can make sense of it. Sound good? All right, so for our problem, everyone, there's going to be trials, there's going to be a probability given, and then we're going to look, you know, what's the odds of certain success occurring. So in this problem, I'm going to say, let's do boys and girls. Let's just say the probability of having a boy is 50% chance. And this is a couple, everyone, and they are going to have 3 children. All right. They plan to have 3 children, so but they're going to have 3 children. The probability of having a boy is 50%. So what's the probability of having a girl? Good. Complement rule. There you go. Well, the question I'm going to ask is, they're going to have 3 children. All right. Just put 3 kids. This is the number of trials. Right? This is the probability. So I just want to point out in this problem that the lowercase n equals 3. That's the number of trials. And in a binomial experiment, these trials do have to be independent events. Do you remember that word? Mm-hmm. All right, don't let it bug you too much, but I guess we can consider them. We'll assume they're at least independent events. The p, that's the lowercase p, that's the probability of success. So you gotta love that word success, because you go, oh, I guess a failure is having a girl, right? But that's the way we talk in probability and statistics. The probability of the success for this experiment is 50%. And then we're gonna get an x value that's gonna come up. That depends on the question. So I'm gonna ask the question now, and we're gonna be able to put the x value here. And here it is. For example, to help us understand this formula, what's the probability they have exactly 1 boy from the 3 kids? So 1 out of 3 kids, 1 of them's a boy, that means 2 of them are what? Girls. And you and I are going to do this. This example is to help us build this math formula. You can notice I used a very small number so we can make sense of this. So I'm going to start out. Oh, I get it. 1 boy and 2 girls. So have a boy and have a girl and have a girl. I wouldn't hear me saying and, so I get to multiply these. And what was the probability of having a boy?
1/3.
0.5, right?
0.5, yeah.
What was the probability of having a girl? And remember how you figured that out? You took 1 and you what? Subtracted that, but it came out to this. And probably having a girl. And multiply these, I'll let you do it. That's 0.5 times 0.5 times 0.5. 0.125. Yeah. Now, this is what's interesting. That's not the answer. And I want y'all to think about this. Look at the question, the way it's asked, and you could say, wait, there's other possibilities. So that's why we do want a formula out of this. Because if we did everything the long way, boy, could it get really, really complicated. Read the question carefully. You're like, that's not the answer. There are other ways to have 1 boy with 3 kids. I just assumed it was the first kid. Doesn't have to be the first kid, right? What's another scenario?
Girl, boy, girl.
Only
Girl,
child.
boy, girl. So everyone, it's either boy, girl, girl. Here comes that word or. Remember or? That means I have to add another probability. Now you won't have to compute problems this way. I just want to present this the long way to see how this formula get built. So that would be, you said G,
B,
B,
G.
G. All right. Don't worry, we're almost done with this one because I think we're almost done here. I just think there's another one.
Girl, boy.
Oh, you're good. Ellen, do you agree? It could be a girl, then they have a girl, and the third kid is a
Boy.
boy. Because look at the word. They just said exactly 1 boy. They never said it had to be the first kid, right? That's my point. So welcome to a binomial probability experiment or binomial probability distribution. There are sometimes many possibilities. So girl, and then a
Boy.
boy. But I don't want you to get too stressed about what I'm doing here now because I'm doing this to build the math formula, right? That you all are going to use. So what's this add up to? This is the real answer.
0.375.
Okay. So, to do this, there were 3 possibilities here. These were called combinations. So how many combinations were there? There were 3 combinations. Okay. So this math formula has to have a combination portion to it. There's going to be a portion of this math formula that calculates the number of combinations possible. In this problem, how many combinations are possible?
3.
Yep. How many combinations of having 1 boy with 3 kids, we're saying there are 3 combinations possible. This formula is going to have that in it. Do you agree? All right, so there's a math formula for that. Now it's called NCX. It's a math combination formula. So I'm going to write it on a board. Some of you may have seen this before. Don't worry if you've never seen this formula before. I'm going to write some symbols on the board. You might look at these symbols and go, I've never seen that before. It'll take me 1 minute to explain the symbols. So I'm going to write the formula out. Here it is. N factorial over x factorial over n minus x factorial. That's the math combination formula. But I'm going to start this thing right here and put it as my first part to the math formula. I'm going to need that. Okay. I'm not here to stress anybody out, but you see that funny exclamation point? It's called a factorial. So it will only take like a minute to explain factorials. 3 factorial, it's called 3 factorial, is 3 times 2 times 1. 6. 2 factorial is 2 times 1, which is 2. 1 factorial is just 1. What do you think 4 factorial would be?
4 times 3 times 2 times 1.
You understand factorials. 4 factorial would be 4 times 3 times 2 times 1. I mean, what the heck would 20 factorial be? That'd be a huge number. 20 times 19 times... Okay, so these are what we call factorials. Anyways, to figure out how many combinations you got possible in the math formula, we do the n factorial, x factorial, n minus x factorial. So and could you do this with me, all this? We should get the answer of what? 3 out of this whole mess. You see this? But this is going to be helpful to us, everyone, when someone says, well, what if you got 10 kids? You're going to have 4 boys. We're like, oh, we can just use this little math formula off the calculator. Cool. So just to make sure this comes out right, does that come out to be a 3? So let's see, what's 3? They write 3C1. They call that 3 choose 1. That'd be 3 factorial over
1 factorial.
1 factorial. And then the parentheses,
2 factorial. 3 minus 1 factorial.
3 minus 1 is
2.
2 factorial. Would you do all that math for me real quick to make sure this comes out to be a 3? Is that equal to 3? 3 factorial is what?
3 times 2 times 1.
6. 1 factorial is 1, and 2 factorial is 2. What's 6 times 1? Or 6 over 2?
3.
Well, Liz, my whole point of this was just to show that this is a key component to this math formula, right? And I'll show you can get off the calculator because no one does this, you're like, do I have to do that by hand the long way? No, there's a button for that.
So the 3 and the 1, you got those from the 1 boy from the 3 kids?
That's right.
Okay.
And I want to point out, so there's always like an n, which is the trials. The x will be the, let me put it right here, the 1, that being the 1 boy. And then this is the probability of success. Okay, having a boy is success, but that's the probability of having the 1 boy. Cool? And we get 3, but I want to show you on the calculator. Where is this button? So go to math, and would you error the PRB? And after we do all this, I get it, and then we'll play the Keno game. Hopefully you'll win. Maybe you'll win. Alright, Owen, would you go to math, and then error over to PRB. Does everyone see number 3? Except rather than NCX, your calculator calls it
NCR.
NCR. Well, to work this button, I'll show it on the screen. Does everyone see NCR? Let me do it again. Math, PRB, number 3. NCR. To work this math, I actually have to hit the number first. So I'm going to hit 1, quit. Let me hit clear. I got to hit the 3 first. Then I hit that button. And then I hit the 1. Ah, cool. Hey, who's got the new calculators? Do you have one? Oh, but yours is better. They should put like a box here, and then the C, and then a box here, and you put the 3 here and the 1 there. You get to fill them in. So when everyone has like a newer calculator, it's a little cooler because you get to just fill that with the 3 and that with the 1. And they hit it when you hit that button. Cool? So everyone, I'm just curious. This is going to be funny. I'm just trying some fun here. What if there were 10 kids? How many combinations of having 4 boys? This is going to be huge. What is it?
Wow.
You see why we never want to work this the long way? Could you imagine you and I trying to figure out 210 combinations? No way! So, anyways, that's the concept. And I'm going to put this on the board. This is the remaining part of this formula. It's got the combination component. Got it? But there's got to be a component for these multiplication things. So there's either a probability of success or probability of failure. So for that, it's p raised to the x. And remember, what's the probability of having a girl? 1 minus what?
Complement.
The complement raised to the... But remember how this was a 1 each time? How many g's did you have in there each time? 2. So the math formula would have to be n minus x up here to this power. But there it is. I know. But I thought we'd compute this, and then I'll let you play the Keno game. Oh, can we do that from left to right? What would be the odds? What should we get for our answer? 0.375? So we should get 0.375. Well, let's see if we get that right now. Here we go. What's the probability of having 1 boy from 3 kids? Here we go. 3C1, 0.5 raised to the 1, 1 minus 0.5 raised to the 2. Someone see how I did all that? And what should I get for my answer? the 0.375. But Liz, I want to make sure how I did this. That was the boy. That was the girl. This was a 1 because it was that value. This power right here came from subtracting these. But to make sense of this formula, we built it. It's like, why was this 2? Remember how it was like 2 G's? That was the 2 G's. This was just the 1 boy. Cool.
So the 1 is our x that you said we have.
That's right. The 1 is the x. And they always have to give it to you in a question when they ask it.
Okay.
And then I just wanted to do it real quick, so I'll hit the lights. Just to show you that we should get this point what? 375. So here I go. Watch from left to right. 3 math, C, NCR, 1. Then I get to multiply 0.5. If you want, you get a multiplication sign here. 0.5 raised to the 1. And then I got to multiply parentheses 1 minus 0.5 raised to the 2. If I do all that, I should get the 0.375, right? Hey, before you leave, this will only take a minute so you can get out of here early. Would you fill out 10 numbers? Will you put your name on this? Take one, pass it back. Hey, next class, Liz or anybody, if that looked a little bit too long, no worries. Next class, I'm going to show you buttons on your calculator where you just fill in the 3 numbers. Okay? So when I'm in the next class, I'll show you the fast way to do this. So make sure to come in the next class. 6. Hey, when you get this, just fill out your 10 favorite numbers. Any numbers in part 3. But would you put your name on it? There you go. Oh, 2 more. 1 more. Will you pass that back? And number 3, put your name on it.
Professor,
Just fill out your 10
how many have we seen?
favorite numbers.
Need
1 more?
Oh, wait, there's 2.
You bet.
Oh, I got you.
You sure?
Yeah.
Anybody else? Maybe you don't want 2 tickets?
I'll take 3.
Hey, what's this for? See, it's on videotape, so you can't say I never said this. Exempt for the final. What else?
Drop your lowest test score.
All right.
So what do
How many numbers?
You get a good weekend. Snow day tomorrow.
How many numbers do you want to
How many
pick?
numbers do you pick?
10.
10. You get 10.
Oh, okay.
Now, and here's the fun part. You're playing the 10th one. I'm going to produce 20 lucky numbers on the screen. All you have to do is have your 10 into my 20. So isn't that cool? I'm going to put 20 lucky numbers up here. Autumn's cracking up.
Right now?
That's why Autumn's packing up.
Are you doing this right now?
So, yeah, we're going to play it. It'll only take a minute. You'll be gone in like a minute. Did you get your 10 numbers?
No. Can I pick my 10 after?
Wait,
That's
what
funny.
if somebody scratches it in? You don't even know.
Autumn, you're going to be my, what do you call it, the sergeant of arms? Look around. Make sure no one's cheating.
Oh, right.
You're my sergeant of
I
arms.
know, everybody's gonna be looking at her briefing.
No, they never
Look,
do.
I got the number.
Hey, in 5 years, no one ever did it, but I need you to be sergeant of arms. I
Yeah,
can
but
manage
what are
that.
the odds of that?
All right. Is that one ready?
No.
All you got to do is hit the 1.
Run.
I'm going to put these on the board so everyone can see them and double check. Now, if I get a repeat number, will you tell me to throw it out?
Okay.
So it's not I'm not cheating you on this game. You just got to have all your 10 in here, right? Come on, you got to win. Did you get them all? Nope, Tia's still going. Autumn's still going.
I'm good.
You're good, Tia? Did you get them? Tia's almost done. Here we go. And I'll write really quickly, everyone. I just hope I don't knock things over here.
So all 10 numbers have to be.
Yep. But that's it. But I'm giving you 20. So there might be some in here now, but all you need is all your 10 in there. You ready, Tia?
Yeah.
Let's play it. Here we go. 54, 45. How's everyone doing? So far so good. 67. 79, 54. Any repeats? The 54, 36. Who's next? We get a
Repeat,
29.
We have a repeat of 54.
Ooh, thank you. She's right. I can make sure I don't cheat. Just no repeats. Let me keep going. 14, 40. The next number is 39, 11, 80.
Oh.
How you doing so far? 69, 5, any repeats? Keep checking in my list here. 5, 39, 27. Any repeats? 2, 56. Is 56 up there?
39 repeated.
Oh, where's the 39? Right there? Yep, so I need a new number there. 52, is that a repeat? 3, 6, 9, 12, 15, 18. Two more numbers. 28 and 6.
6 is already, oh, never mind.
How'd y'all do? Did anybody win?
Wait, I got two numbers. You have all 10?
Should we play it again next class?
Yes.
Who got the most?
I can't even keep
Let
count.
me see. I don't know.
Who got none? Did you know you actually win money for that? Look on the back. You win like $4. I'm not gonna give it to you. So no one came close to 10. What was the closest to 10?
No.
Hey, we'll keep playing this. Next time I'll throw my vehicle in. Have a good weekend.
That depends on what the vehicle is.
Right.